Hi, and welcome back to the Lil Will Learning Company. And when it comes to math, boy, math can be one of those subjects where a student feels very competent, feels very confident, and some who just they don't get it. They cry about having to solve 10 to 15 different problems, whatever the case may be. Math is one of those things that really should be a universal skill. It speaks across all languages. But what does good math, let's say, education look like? What are the main things that if you have a student, what are the things they should practice in math? If we had to break math down into four components, it ultimately comes down to calculation, fluency, word problems, and reasoning. And in a good math education, if math is being taught really well, all four components are always present. It just depends on to what degree or like to what percentage or what ratio. And as the math skills are taught and practiced by students, the amount that you emphasize between calculation, fluency, word problems, and reasoning, it kind of changes. And I know it can be a bit complex at first. I want to go over so many examples today, but I want to really break down why it is that these four components, when they're taught, and maybe even taught kind of separately at first and then eventually kind of worked together, it's what makes the students really, really strong in math. So the first component is calculation. And I think for the majority of people, when they think of a math classroom or a math lesson, this is typically what you're thinking of. So math calculation means teaching all the essential math skills in order for a student to correctly calculate an operation. So it's teaching them counting, addition, subtraction, multiplication, division, fractions, decimals, number lines, you name it. And when you start to think of all the skills a student learns in math, that's really where calculation comes from. It's the absolute foundation of math because if a student can't calculate correctly or if it's just too difficult for them, the other components we're going to talk about, they they almost don't even come into play at that point. And I'm very old school with this, but I talk about calculation without a calculator. I mean that the student can do it on, let's say, paper, pencil, and nothing that just gives them the answer. Being able to actually calculate it out is very important. Now, there is a pattern to kind of how to very efficiently teach this, and it goes by many various names. I always like to use stuff from John Wooden, and he always says that in order to practice something and then really to learn something, you have to do an explanation, then a demonstration, then you have the students imitate it, and then instead of saying practice, he says then repetition. Basically, do it a lot very intentionally. And that's how you learn any skill. And that's a really appropriate way in order to teach math, in order to teach math calculations as well. By teaching it in this way, it gives a lot of clarity to the students. And basically, it helps them to avoid repeating a lot of mistakes. And the truth is, if a student is weak in calculation, then ultimately all the other components of math begin to fall apart. So once calculation has been taught, the next component in math comes down to fluency. And basically what fluency means is when they calculate it, are they accurate? Just basically means are they correct? Can they do it with great speed? And can they do it with automaticity? And you've heard me probably talk about this with reading. Automaticity means essentially it kind of comes about very easily. And you want the same thing with math. You want that these calculations happen with relative ease. You want automaticity. Now, a really good way to do this, aside from just giving a student 60 problems to practice and just go over and over, a drill and kill, well, I mean, having repetition of practice is important, but a really good way to improve fluency is just mental math. And with mental math, it means there's no paper, there's no pencil, and they have to do the calculation in their head. Now, mental math is a really important part of math fluency because, again, it starts to improve not only the speed, but the automaticity as well. Because now without the paper and pencil, they have to really think about the calculation in their head. and come up with the answer, and that will help with the next two components as well. But mental math is something that is really important for developing a student's fluency in math facts, math calculations, etc. Because without that fluency, what happens is just like with reading, the brain it takes too much energy, too much focus on the calculation, whereas that fluency, it frees the brain up to do other things besides just that one calculation at that moment. Fluency basically frees up thinking for the student. The third component is problem solving. And when we say problem solving, probably a easier way to refer to it would be word problems. And probably an easier way to think of word problems is just any math problem, but presented in the written word or explained through a problem where it has to be read through words. This is a silly explanation, but essentially that's what it comes down to. What makes it more, I guess, interesting or more nuanced is that there really isn't just one type of word problem. And that does make it more difficult for some people. Well, they think, well, I see a math problem. It's been written in words, therefore it must be a word problem. Yes, that's true in one sense, but there's more to it than that. So probably a good way to think of it is in order to help students, again, become good math students, there's three types of word problems that can be presented to them. So the very, very first one is something that's called structure based. And this is probably the simplest one. It's one that any of us could just make up on the spot. But let's say there's a computational skill that they've been practicing at that moment. Let's just say it's subtraction. And then you give them a problem that is clearly just a subtraction problem like they've just been doing, but it's written as a word problem where, hey, Johnny starts off with 25 apples, but then Johnny trips and falls, and 18 of the apples fall down a hill forever, never to be caught again. How many apples does Johnny have left? Now, although we feel bad for Johnny, it's just a straightforward computational problem. The next one is a multi-step problem where it's similar to word problem type 1, but now there's multiple steps involved, and along each of those steps, maybe there's a different operation that needs to be used. Maybe in step 1 of the problem, you have to do addition, but then by step 2, you have to do percentages. And for example, it could be one of those things where what is the total cost of all the items that are picked up at the store? And then what's going to be the cost per person if it's going to be split between 8 people? So that would be a multi-step word problem. That's type 2. Now, type 3 word problem is what we call something that's more complex or non-routine. And there might not be an operation that's used at all, and it's more analytical, spatial thinking. An example I could give of that is, let's say you have a cake, and you have to put candles on the cake that go on top of the cake, but around the perimeter of the cake, so to speak. And they must be an inch away from the edge of the cake, but the candles must also be an inch apart from each other. But you can't have two candles at the corners of the cake, and the cake is 4 inches wide by 6 inches long. How many candles can fit onto the cake? And for these, you usually have to choose a strategy to use to solve these. And with that, it takes a lot more thinking and seeing if your answer makes sense. But those are what we call, again, non-routine or more complex word problems. Now, there is kind of a fourth one. I personally wouldn't call it a type of word problem, but some consider it to be. Type 4 would just be taking real life problems and then taking the math and solving it. But again, usually, in my opinion, if you look at real life problems, it falls somewhere in the spectrum of a type 1, 2, or 3 word problem. And so, I don't know. I don't really count that, but they are still legitimate and they are helpful for having students learn how to problem solve. The fourth component of math education comes down to reasoning. And all this really means is, can the student explain their thinking? So the nice thing is, the first component is computation. The second component is fluency, especially when you do mental math. The third component is word problems. But at the end of it, can they explain what they were doing? I want to give a few examples of this. So let's take a student really early on with addition, and they have to explain 8 plus 7. And let's say they do some mental math, they come up with 15, but then you ask them, "Well, how did you get that?" And maybe some would say they count along their fingers, so maybe the next time you say, "Okay, now you can't use your fingers, how'd you get that?" And some might say, "Well, 8 plus 7, I took the 7 and I basically cut it into a 2 and a 5. And I did 8 plus 2 first to get 10, and then 10 plus 5 to give me the 15." And by all means, like, their thinking is reasonable and it makes sense. They explained their thinking. Another one would be 12 times 15. And again, you say mental math, solve 12 times 15. Let's say they get the right answer and you ask them to explain it. So basically, they could say, well, I had 12, but I divided 15 into a 10 and a 5. I did 12 times 10. I did 12 times 5. 12 times 10 is 120. 12 times 5 is 60. 120 plus 60 is 180. So 12 times 15 is 180. Now, again, great mental math, but at the same time, the fact that they could explain their reasoning back to someone, that's a really important component of math education, because what it ultimately shows is that the student understands the whole math process. They understand what's going on, and they can verbalize it back. They can communicate it back to someone else. Now, when it comes to reading, I've talked about four components of reading and how they build into the next one's next, the next one, and the next one. And math kind of has that. I mean, it does have that. You need to learn calculation first, which then helps you to do math more fluently and hopefully just mentally in your head, which then ultimately can lead you to solving word problems, hopefully all three types of word problems, and then the fourth component where you can explain it back. There is kind of a progression to those components, but the truth is that through math, once you're done learning addition, then you learn subtraction. Then when you're done learning subtraction, then you start to learn addition and subtraction of larger numbers. You're always moving on to a new type of skill that you have to calculate. And so ultimately what happens is you're going to take each of these new calculation skills that you learn, and you're going to apply fluency, you'll apply word problems, and you'll apply reasoning in various degrees with each of the skills you know. If it's a student who's a third grader who's been doing addition for 2 years, you would probably heavily press word problems and reasoning much more on that skill. But if they're just learning multiplication, you're probably going to have them practice more of the calculation and then a bit of mental math, as opposed to a lot of word problems and a lot of reasoning. So it depends on which classroom you're in, where some components are pushed more than others. And the truth is, you kind of have to teach them separately, but then you do have to apply all four in various degrees, depending on how well the student knows that specific math calculation or skill. And that's really important to understand. It takes some skill and some experience to understand, like, how much of each dosage of each component that you apply in that moment for that student. So ultimately, that's important to remember. When you're a good math program, it's not just one skill or one skill set. It's these four components working together. And even within those four components, there's various things you can do. And if they're learning their calculation well, if they can then be very fluent with it, especially mentally, and there's a lot of automaticity to it, then they can apply it to various types of word problems, whether they're structure-based, multi-step, or more complex word problems, and they can explain their reasoning. That covers a lot of good math education, and students will be off to a very good start with that. And if you or yourself or your child needs help with any of this, I did write Arithmetic from beginning to end, and I did write Direct Approach to Solving Math Word Problems to help out with these skills. And if you like what you've heard so far, please like and subscribe to the Lil Will Learning Company, and come check us out on our website. We have things, like I said, for math, such as arithmetic, and word problems. We also have phonics and reading fluency, and soon to have spelling curriculum and whole year long curriculum for grades. Come check us out. And until next time, take care.